Okay, the next section just puts it into context. So it's talking about, at the top, it's giving you just some information. So 2 commonly used quadratic models for falling objects near Earth's surface are the following. So distance, which is 16t squared, or height, which is initial height minus 16t squared. Okay? So all we're doing is we're using these 2 equations and applying them to word problems and solving. So example number 2 says, write and solve an equation to answer the question. Give the exact answer, and if it's irrational, a decimal approximation to the nearest tenth of a second. Oh, so we get to type it in their calculator. You guys, so much fun. If you drop a water balloon, how long does it take to fall 4 feet? So we're using the distance model. So distance is 16 times t squared. Solve the equation. Where does this equal 4? So they set it up. They divided both sides by 16. They took the square root of both sides. They rationalized the denominator, because this was like saying the square root of 1 over the square root of 4. Well, the square root of 1 is 1, and the square root of 4 is 2, so we end up with a positive or negative 1 over 2. So that's how they did that. Okay, so B, okay, so this one was this, how long does it take to fall 4 feet? So this one was just a distance equation. If we look at B, the rooftop of a 5-story building is 50 feet above the ground. How long does it take the water balloon dropped from the rooftop to pass by a 3rd-story window at 4 feet? They've given you 2 heights, guys. This is how we know we're doing something weird, okay? So we're going to plug in what we know. So our initial height is where it started. So our initial height is 50. And we want to know how long, what's our t, for it to hit 24. Okay, so first we subtract 50 from both sides, and we end up with negative 16t equals 46. We're going to divide both sides by negative 16, and that was a negative, not 46, 26. Okay, so now I'm going to turn on my calculator. It's restarting, guys. Almost done. Thinking. Okay, I'm going to start a new document, so I'm going to do number 1. No, I don't want to save the original one. I'm just doing a calculator, so I'm doing number 1. And I want to do negative 26 divided by negative 16. Negative 26 divided by negative 16. Enter. It's a fraction 13 over 8. So I get t squared equals 13 over 8. Take the square root of both sides. We end up with the square root of 13 over 8, which is the square root of 13 over the square root of 8. Square root of 13 can't be simplified, but the 8 is basically 4 times 2. So that's the square root of 4 times 2. Well, the 4 will come out. Square root of 4 is 2. That square root of 2 will stay underneath. We can't leave that square root underneath, so we're going to have to multiply by square root of 2 or the square root of 2. So we end up with 13 times 2, square root of 26, over 2 times the square root of 2 times the square root of 2, which is 2 times the square root of 4. Keep going. That's simplified to a 2, so we end up with square root of 26 over 2 times 2, which means our final answer is the square root of 26 over 4. And we can type that into our calculator. So plus or minus, really not a minus, square root of 26 over 4, which is approximately control squared 26. Control divide turns into a fraction. Nope, that's not what I wanted to do. Okay, fraction. square root of 26. On the bottom, we're putting a 4. We're going to hit enter. It says round to the nearest tenth. So 1.27, the 7 rounds a 2 to a 3. So it's approximately 1.3 seconds. And that's how we would solve a word problem with these squares. So let's do the your turn. Number 6. How long does it take the water balloon described in part B to hit the ground? Okay, so part B is what we just did. Okay, how long does it take to hit the ground? So we want to know when will that equal 0. So same equation, except it's going to equal 0. 50 minus 16t squared equals 0. Subtract 50 from both sides. Negative 16t squared equals negative 50. Divide both sides by 16. We get t squared equals 50 over 16. I'm going to simplify that first. What is 50 divided by 16? 25 over 8. Take the square root of both sides. So we end up with, I'm going to move this over here. T equals the square root of 25 over the square root of 8. Well, I know the square root of 25 is going to be a plus or minus 5. 8 is really 4 times 2, and 4 is a perfect square. So the 2 can come out and a 2 stays in. And again, we can't leave that square root on the bottom, so we're going to have to multiply by square root of 2 over square root of 2. So we get 5 square root of 2, plus or minus, 2 times square root of 2 times square root of 2 is the square root of 4. So we get 5 square root of 2 over 2 times 2. So my final answer, t equals 5 square root of 2 over 4, which is approximately, control fraction, 5 square root of 2 over 4, enter, 1.76, the 6 rounds to 7 up, so approximately 1.8 seconds. Number 7. On the moon, the distance in feet that an object falls in t times seconds is multiplied by the function of this. Suppose an astronaut on the moon drops a tool. How long does it take the tool to drop 4 feet? So 8/3 t squared equals 4. I'm going to divide by 8/3. So what is 4 divided by the fraction 8 over 3? 3 halves. T squared equals 3 over 2. Square root of both sides. T equals square root of 3 over the square root of 2. Can't leave that down there, times the square root of 2 over the square root of 2, which means I have the square root of 6 over the square root of 4. I'm going to leave that up top, but that's going to come out and be a 2. So t equals square root of 6 over 2, which is approximately fraction square root of 6 over 2. The 2 keeps the 2 the same, so approximately 1.2 seconds.